Hey guys, on today's video, we're looking to solve a question that many Year 11 students struggle with, and that is a limiting reagent molar volume type question. So the question is, when 24 grams of ethanol is burned with 9 grams of oxygen, what volume of carbon dioxide gas measured at 35 degrees and 0.95 atmospheres would be produced? To solve this question, we need to do three things. The first thing would be to write a chemical equation. The second thing is that you need to realize that this is a limiting reagent type of question. And the reason why is because the question doesn't specify we have an excess amount of oxygen. All it says is that we used 9.00 grams of oxygen. And the third thing is, because this is a volume question, we need to decide whether this is a question that involves using the molar volume formula or the ideal gas law formula. But because we're not using 0 degrees Celsius or 25 degrees Celsius or even at 1 atmosphere, we know that this is an ideal gas law question in which we're going to be using the formula PV equals nRT. So now that we have those three things figured out, let's go ahead and solve the question. Okay, so writing the chemical equation. So what we have is we have ethanol burning with oxygen, and that gives us carbon dioxide and water because it's a combustion reaction. So remember, you need to balance your equations before you go ahead. So what we have is 3 oxygens, 2 carbon dioxides, and 3 waters. So the next step is finding whether ethanol or oxygen is the limiting reagent. So the best way to do this is to test both of them. So looking at ethanol first, we need to equate the number of moles of ethanol to the number of moles of CO2. So what we find is that we need 2 times the number of moles of ethanol to equal to the moles of CO2. Now we need to equate everything to CO2, and that becomes 2 times 24 grams, which is what's given in the question, over the molar mass of ethanol, which is 46.08 grams, and that gives us 1.04 moles. So because in the balance equation, we find that we use 3 moles of oxygen to produce 2 moles of CO2, all we need to do is cross multiply to find the number of moles of oxygen to equalize the number of moles of CO2. And again, just rearranging the numbers and equating CO2, we have 2/3 times 9.0 grams, which is given in the question, over 32.00 grams, which is the molar mass of O2, and that gives us 0.188 moles. Okay, so now we can actually determine the limiting reagent. So now we can see that oxygen is actually the limiting reagent in this question. So what that means is that we're going to be using the 0.188 moles of CO2 produced to find the volume of CO2 gas. Okay. Now we got to use our ideal gas law, which is PV equals nRT. And remember, temperature is always Kelvin. And so what that means is that the 35 degrees given in the question needs to be converted to Kelvin. And what that means is we have T equals to 273 plus 35, and that gives us 308 Kelvin. So now we are just rearranging the formula, and that gives us V equals to nRT over P, which equals to 0.188 moles times 0.0821 times 308 Kelvin divided by 0.95. And that equals to 5 liters of CO2 produced. Thanks for watching today's video. I hope you got a lot out of it. If you have any more questions in regards to chemistry or even physics, please send me a message.